Every day, hundreds of cyclists fall victim to dehydration because they simply cannot fit their oversized water bottles into their water bottle cages. Hi, I'm Benjamin Moss. Cyclists everywhere are finding new ways to transport their water bottles. Some use belts, others risk it all. This senseless tragedy can be avoided entirely by using the variable water bottle holder. This water bottle holder allows cyclists to hold their oversized water bottles on their bike. This unique design allows for easy access to the cyclist to their water bottle while still holding the bottle securely. Please, help us stop this epidemic. You're probably wondering why I'm up here and why I'm talking to you guys and why I'm breaking the fourth wall. I can explain that. See, I'm going to be your guide, kind of like Alton Brown. So from here on, in order for us to actually come up with a design, we had to come up with some criteria. So the criteria we decided to fulfill were we needed a water bottle holder that can hold more than one size of water bottle. Specifically, can hold a Nalgene perfectly, can hold something a little bit bigger than a Nalgene, and then a disposable water bottle. So it had a degree of variability. The second thing we needed was for it to lock in place and be secure, because the last thing you want on a long bike ride is to lose your water bottle. So my idea is to create a case that will encase the whole mechanism, and it'll have two zip ties running around that the water bottle will fit into. These zip ties will firmly grasp the water bottle when you actually put it in.
Firmly grasp it!
So you have something for the water bottle to sit onto. Next, inside here, you have a single long gear that will engage the actual zip ties in tightening around the water bottle.
Yes, I know.
This is the absolute worst.
Talk with Glenn.
You lost me there, man.
Yeah, I'm not really quite sure what I'm looking at.
My design will run along a slider that has pinholes that you can lock the slider in place, and then has two hinges that will run along, which will connect to claws on the outside of a case that run along these paths. And so then you'll have a outside claw and an inside claw that can hold variable sizes of water bottles.
You could use some work. So when you get your bottle, you slide it down in there and it adjusts the claw to come in like that. So in order for that to work appropriately, we had to do 4 triangles to move the 4 claws, and the triangles are offset to allow for the claws to overlap whenever we are going to the smallest diameter water bottle. So the triangles you see are longer this direction than they are this direction. So this gives you our maximum throw, and this gives you the movement. So whenever this is a steeper triangle, it moves quicker, but there's less fine adjustment. With a longer triangle, it gives you finer adjustment, but you have to we ran into an issue with going too fine because we had to add a ratchet mechanism to lock the slider in place once it got to our optimal point for the bottle chosen.
I'm here to provide you guys with context. See, from here on out, we decided to go with a culmination of all of our ideas. You know, we mostly used Sam's because, you know, he's a smart guy. And we included Bryce's claws. My idea was pretty stupid, so we ignored that one. But from here on out, we're about to have Bryce explain to you how we optimized the claws. And if you were wondering why I look so big, I'm on a super wide angle lens from my GoPro.
Alright, this is the analysis for the variable water bottle holder. So we start out based on the optimal diameter of an Nalgene water bottle, which is 3.6 inches. Now, leaving some space for the rubber inserts that the claws can hold on to, we create this new diameter, which is 4.1 inches. Now, our claws will just reach across that diameter to be able to grab onto our water bottle and have the rubber inserts to grab the water bottle. We will just make a tangent line for the claws to reach to the bottom and pivot on those corners. Now, we have our optimal design, so to be able to insert an Nalgene water bottle. So that will be that tangent line, the radius, the curve back. And so if we make the optimum range our middle ground, then we can just use the same radius on the inside as our minimum. And so now we have our 3 optimal spots, our midpoint, our outer point, and our inner point. Now we need to be able to move these claws. So taking the tangent line and making it slightly longer, and then pulling in a arm to be able to, for our slider to move on, it will be able to have a triangle on the slider that will move the claw outwards as the slider moves in.
FDM 3D printing was chosen to manufacture the bottle holder. 3D printing enabled us to easily print several prototypes and test pieces throughout the design process to test our ideas and improve our design. PLA was the material choice for its low cost, ease of printability, non-toxicity, and sufficient strength for our purposes. Like any form of manufacturing, FDM printing has its share of considerations for design. Among these are keeping strength demands limited to the X and Y direction, eliminating the feasibility of an all-in-one print option for us, designing for little or no support material, and tolerancing your parts appropriately. As with most 3D printing, not everything went perfectly, and late changes to the design produced some less than sturdy results in the final prototype that wound up breaking off with the support material. But we adapted, and were still able to save our print with a little glue and heat. With the prints complete, some post-processing was required to assemble the bottle holder and get it in working order. As a final step, a couple of scrap pieces of rubber, discovered in the workplace, were glued to the surface to enhance grip.
So, now we get to talk about improvement. To make this thing a little bit better, we decided if we had a little bit more time, we could add a couple springs. One spring could be added to the actual slider mechanism itself, so when you press the release button, it kind of pushes your bottle up. Our next thought would be, to shrink the entire thing, because it is a little bit bulky on a bike. That could also help with some fatiguing as you use it more. And also the smaller size could actually be able to be added to a mountain bike, which would be pretty ideal.
And now, folks, it's time to say goodnight. We sincerely appreciate your patronage and hope we've succeeded in bringing you an enjoyable evening of entertainment. Please drive home carefully and come back again soon. Good night.